Okay, we were taking another integral. This one's from the SwinBee 2023, problem 16. We have the integral of 1 over x to the 8th times x squared plus 1 dx. Okay, I thought this one was really interesting because I had to do it a few different ways on paper. My first attempt, I just did partial fractions on this, and I found it to be pretty tedious. Even trying to get a few shortcuts, it was still tedious doing the partial fractions. Then afterwards, I did this with trig substitution. It worked out fine, but it was still kind of slow. So what I want to do with this instead is try to get some simplification with algebra first, and I'm just gonna move the dx out of the way, and we'll just think of this as a 1 here in the numerator. And what I want to do is find some way to get some cancellation. What I can do, if I add x to the 8th into the numerator, then when I split this up into two integrals, we know we're going to get cancellation here with this. But of course I don't want to change it, so what I'm going to do is subtract off that x to the 8th. So then here we're just adding 0. So then we'll go ahead and split this up. I'm going to first do the 1 minus x to the 8. I'm going to keep that in a separate integral. So we'll have 1 minus x to the 8 over the same denominator. And then the second one, this is where we want to get the cancellation with this positive x to the 8. So we'll have x to the 8 over all this. But that way the x to the 8's cancel right there. So this right here is going to be an easy integral. This is just going to be arctan. Now coming back to the first integral, what we have here doesn't really help too much. This is just as hard as what we started with probably. But what I want to do now, we can actually come and factor this. And what we can do, and for this we can use difference of two squares. So I can write it as 1 plus x to the 4th times 1 minus x to the 4th. But then this is difference of two squares as well. So for this one we can write this as 1 plus x squared 1 minus x squared. But then let's just take this 1 plus x to the 4th times this and put it back. So when we multiply that out, we're going to have 1 minus x squared plus x to the 4th minus x to the 6th. And then we'll bring down this piece, this 1 plus x squared. But now if we take this and put it back in the integral, we're going to get some cancellation because we have this 1 plus x squared in common. And now with this rewritten, we can just cancel off the x squared plus 1s, cancel off x squared plus 1s. And what that allows me to do is now I can just divide the x to the 8th into the numerator. So let's see what happens when we do that. So for the first term, we're going to have 1 over x to the 8th minus 1 over x to the 6th plus 1 over x to the 4th. We have this alternating sign thing going on. And then for the last one, we have minus 1 over x squared dx. For this one, we'll just go ahead and integrate it because this one is just going to be arctan of x. But now everything here can just be done with power rule. You could bring this into the numerator, right? That says like x to the minus 8, x to the minus 6, etc. I'm just going to leave it like this and do the power rule the way it is. So for this first one, we're going to have minus 1 over 7, x to the 7th. Here, we change the sign again. We're going to have 1 over 5x to the 5. Here it becomes minus 1 over 3x cubed. And then for this last one, 1 over x plus arctan of x, add a plus c, and that's it. Anyway, thought it was a pretty good one today. Thanks everyone for watching. Have a good day.